Hi students, welcome to Time. Today we are going to discuss some questions in the chapter Measurements and Motion, the subtopic Physical Quantities. Hope you are thorough with the basics of the concepts. Okay. Before starting with the interactive exercises, I would recommend you to go through the exercises in the chapter, do it yourself, then come back to resume the video and watch whether whatever the answers you have marked are right or wrong. Okay. Now, let us begin with the texture basics. Say, fill in the blanks. Okay. Let us look at the first question. In SI system, mass is measured in dash. Just have a recall. Mass, one of the fundamental physical quantity. What is the unit? Gram, milligram, kilogram, so on, right? So, in SI system, what is the unit? Yes, you are right. It is kilogram. Fine. Let us look at the next question. Okay. Unit of dash is the same in all systems of measurements. Basically, we have three systems. SI system, CJ system and FPS system. Okay. So, for suppose we can take also the MKS system. MKS system or SI system is a modification of the MKS system. Fine. Now, in all the systems of measurements, one particular physical quantity has the same unit. What is it? Have a thought. Yes, it's time. And what is the unit? Yes, obviously it is second. Fine. Now, let's go to the next question. In dash system, there are 7 fundamental quantities. So, what is that system? Yes, you are right. It is SI system. System International. When you take it in the French notation, in the English version, we will call it as the International System of Units. Okay. In that system, we do have 7 fundamental physical quantities. Fine. Let us go on to the next question. Prefix used for a factor 10 power minus 6 is. What is the prefix? You know there are certain prefixes, right? For the units what you are taking. So 10 power minus 6. Have a guess. Yes, it is micro. Clear. 10 power minus 6 stands for micro. Let us look at the next question. Mega is used for a factor of dash. Just now we have seen about 10 power minus 6. Mega. Mega is what? Yes, it's for 10 power 6. Okay. So far we have done with some fill in the blanks questions. Let us look at now some multiple choice questions. So, we need to select the correct alternative from the given choices. Okay. First question. Which of the following is a fundamental quantity? Length, area, volume, force. So, if you have the view of or if you recollect all the 7 fundamental physical quantities in the SI system, it's not so tough to answer this question, right? Simple. Area, volume, force. So, to measure all these 3, we need to depend on some other physical quantities. We are aware of it, right? Whereas, length, we will measure length directly. So, what is the answer? Obviously, it's the length. Let's see the next question. Which of the following units is a derived unit? You can see cubic meter, Newton, meter square, all of these. So, what do you mean by derived unit? Derived unit is something, the unit of a derived physical quantity, right? So, here what's happening? Cubic meter. So, cubic meter is a unit for volume. Newton, it is a unit for force. Meter square, unit for area. So, if you say volume, force, area, all these are derived physical quantities, right? So, obviously, it will be all of these. All of these are derived units. Okay. Let us see the next question. The unit of electric current is denoted by electric current. What is the unit of electric current? Yes, it's ampere. And what is the notation for ampere symbol? It's A. Clear? So, let us go to the next question. Prefix used for 10 power minus 3. What is the answer? Is it micro, mega or kilo or milli? Which one? What is for kilo? 10 power? Yes, it is plus 3. Mega, 10 power 6. Just now, very recently we have seen that. Okay. Micro, yes, you recollected right, it is 10 power minus 6. So, remaining is for milli. So, 10 power minus 3 is milli, right? Next one. Prefixes used for negative powers of 10. So, when you are talking about negative powers, okay. So, we have positive powers as well as negative powers. What are positive powers called for 10? Right? Its multiples. Okay. As far as negative powers are considered, it will be submultiples. Okay. So, units, it's not the units actually. It's not standard, because standard of a physical quantity is a unit. So, both are not the answers. 1 and 4 is not the answer. Wherever negative powers is there, that we'll call it as the submultiples, and positive powers we'll call it as multiples. Let us look at some knowledge based questions in the subtopic measurements and motion, physical quantities. Okay. Let us look at the first question. Define a physical quantity and give any two examples. So, here you wanted to define what is a physical quantity. How do you define a physical quantity? What exactly is a physical quantity? Physical quantity is something which can be measured, right? So, that is how we define it. A quantity which can be measured is called a physical quantity. Simple, that's it. That will be the definition of a physical quantity. Now, two examples. Let us take two examples, time and speed. We have so many other physical quantities also. Other examples we can take length, mass, area, volume, density, temperature, so on and so forth. Any number of examples we take, any two examples we can give. Okay. Let us move on to the next question. Define a derived physical quantity and give any two examples. Now, what is a derived physical quantity? We know what is a fundamental physical quantity, right? Its measurement does not depend on the measurement of other physical quantities. So this will be like a physical quantity which is dependent on other physical quantities. Okay. So, if you can also say that way that, okay, it is also a physical quantity whose measurement, when I say which is dependent on other physical quantities, I mean to say that the measurement of a given physical quantity will be dependent on the measurement of other physical quantities, right? Let us take some examples. Speed, distance by time. Okay, distance divided by time will give you the speed. Area is length into breadth actually. Breadth basically being length, we can write area as length square. Similarly, if I take another derived physical quantity, say volume. Volume is what? Area into height. Height is again length. So, I can express it as volume as area into height or area into length. Okay. So, it will become length cube. Okay. Length into length into length. If I multiply, okay, 3 times, then I'll write it as power as 3. If any number, suppose A, I am taking A, if I am multiplying with A, it is called A into A power square. Sorry, A power 2, which is called as A square. Similarly, if I multiply with another A, so A square into A, if I take, this will be A cube. Power 3, A power 3 is called A cube. Is it clear? So, whatever the powers, how many times you are multiplying, that will be the power of that particular quantity. Is it clear? Hope this point is clear for you. Now, let us move on to the next question. Fine. Define multiple units. Prefix used to represent higher values of physical quantities are called multiples. Now, you tell me what is the multiple. 10 power 2, 10 power 3, 10 power 6, 10 power 9, all these are the multiples. We know, we are familiar. See, 10 power 3 is called as kilo, right? 10 power 6 is called as mega, 10 power 9 as giga, so on and so forth. Okay. So, if at all we have lesser numbers, that means negative powers are there, 10 power minus 1, minus 2, minus 3, those will be called as the submultiples. Okay. Let us move on to the next question. Define unit and write any 3 examples. Okay. So, what is a unit? How do you define a unit? We know in measurement, it is nothing but comparison of a given physical quantity with that of another physical quantity, which is a standard, right? So, the standard is called as the physical quantity. Standard reference of a physical quantity, that's what you call it as unit. Now, let us see some examples. For length, you take it in meter. For time, it is in seconds. And for mass, it is in kilogram. Is it clear? So, these are some of the units of some physical quantities. So, much more you can take. We know there are 7 fundamental physical quantities in the SI system. Okay. Temperature, it is measured in Kelvin. Luminous intensity is measured in candela. So, all these will be the units of those fundamental physical quantities. Okay. Let us look at the next question. Okay. Define fundamental unit and write any 2 examples. Okay. So, fundamental unit. We saw what is a unit. So, when I say fundamental unit means what? Unit of a fundamental physical quantity. This is how we will define it. Units of fundamental quantities are called fundamental units. And what more he is asking? Any 2 examples. Okay. Example, gram, meter. So, gram is a unit of what? Mass, and meter is a unit of length. Clear? Similarly, another examples if I wanted to take, I can take say Kelvin is a unit of temperature. Here, we will discuss about the understanding based questions in the subtopic physical quantities, measurements and motion. Hope you are comfortable with the subtopics, the concepts in the subtopic, and also you are done with the texture basics part, okay, and the knowledge based questions. If at all you are not thorough with those concepts, I would recommend you to go through that particular part of the video, go through the video once again to be clear on the concepts and get back to this questions part. Okay. Before you proceed for the questions part, watching the questions part, I would recommend you to go through the understanding based questions, answer for yourself once, and then resume to watch this video so that you will be able to understand whether whatever the answer you have kept, whatever the way you have solved the question is right or wrong. Okay. It is not just only the answer which matters, but the way you solve it, the way you analyze the question, that makes a difference. Okay. So, let us go with the first understanding based questions. Okay. First question is this. What is the SI unit of ratio of the mass to area? What is given here? What is the SI unit of the ratio of mass to area? So, here we are talking about the ratio. Ratio of what? SI units of 2 physical quantities. What is the physical quantity? One is the mass and there is area. Okay. Let us put this way. SI ratio of, what is the SI unit of? Ratio of mass to area. So, I will write first mass divided by area. Okay. So, I want the SI unit of this ratio. That means, this will be SI unit of this particular quantity. SI unit if I take, this will be equal to what? SI unit of mass divided by SI unit of area. Okay. Now, hope you are familiar with the SI units of this. Out of these two, if you consider, mass is a fundamental physical quantity, whereas area is a derived physical quantity. Clear? So, what is the SI unit of mass? Yes, it is kg. So, kilogram. Okay. And SI unit of area? Area is what? Length into breadth, right? So, basically, breadth is also a length. So, I can express area in terms of length into length. So, now I will be getting the unit of area as unit of length into unit of length. What is the SI unit of length? Yes, it's meter. So, meter multiplied with meter, that is meter square, will be the unit of area. So, I will be getting it as meter square over here. So, I can write the same thing as kg per meter square, which is the standard way to express the units. Okay. Hope you are clear with the question. Let us look at the next question. Write the correct notation for the following. So, we have given 5 things over here. 2 kg, 4 Newton, 6 meter, 35 gram, 7 seconds. So, these are not given in the correct notation. What is the problem over here? K is in the uppercase, 2 kg. Because when you are writing the units, we should follow the standards, right? So, this K, kilo, which is the prefix, should be used in the lowercase. So, I can write in 2 kg, or if at all I want to write in full, I will write in 2 kilogram. When I write in full, I can write kilogram, but even then K should be in the lowercase. Next one, 4 newtons. So, you should not say 4 newtons at all, you should say 4 Newton, because unit is not plural form. Unit should not take the plural form. Okay. So, when I say 4 newtons, here there are 2 mistakes in this particular notation. One is Newton is a unit of force which is named after the scientist. Okay. So, when you are writing in full name of the unit, that N should be in the lowercase. The beginning N should be in the lowercase. Second thing is that you cannot use the plural form of it. Okay. So, I should write in 4 Newton like this, or if I wanted to write only the symbol form, this is the name of the unit. If at all I want to write only the symbol form, I should just write N as per the rules. Is it clear? Next, coming here, 6 meter. Same is the case. Here we have meter, METERES. This S should not be there because it cannot take the plural form. Okay. Either I should write in 6 meter, or if at all I wanted to write in only the notation form, symbol form, I can write only 6m, that's it. Okay. Now, coming to the fourth one, 35 gram over here. So, gram, you see clearly over there, G is written in the uppercase. That is the problem over there. That's the wrong. Okay. So, I should write in 35 gram like this, or if at all I wanted to write only in the symbol form, for gram it is not GM, it is G, that's it. So, 35G, that's it. Clear? And what is the mistake in the last one? 7S. 7 seconds. Okay. So, when I say 7 seconds, actually I should not say seconds, it should be 7 second. Clear? So, when I say 7 second, that S should be written in the lowercase, not in the uppercase, because S in the lowercase is the standard symbol for second. So, I should write it in second like this. If at all I want to write in the full name of the unit, I can as well write 7 second completely. Is it clear? Hope the notations, the correct notations for this particular things given is clear to you. Now, let us look at the next understanding based question. Okay. So, match the entries in column A with the entries in column B. Here I have, see, SI unit of electric current, CGS unit of time, SI unit of luminous intensity, SI unit of distance. This is the things entries in the column A and corresponding entries in the column B we have. So, we need to match them. First one, if you see SI unit of electric current. What is the SI unit of electric current? Yes, it's ampere. So, where is ampere? So, B. So, it should be B over here. Okay. Next, SI unit, CGS unit of time. Unit of time, CGS or SI unit or FPS system, whatever the system you take, it is the same thing. What is it? Second, right? So, where is it? Here. So, it is D. Clear? So, SI unit of luminous intensity. Even if you suppose that you don't know, you don't remember what is the SI unit of luminous intensity, the fourth one, if you see SI unit of distance, this is very clear, na? SI unit of distance is meter. So, where is meter? This one, C. Okay. C I will write here. What is left over? A, that is candela. So, that should be the unit of luminous intensity. Okay. Better you remember the SI units of all the 7 fundamental physical quantities. Okay. Even if you forget 1 or 2, there is not an issue. based on the logic, we need to apply the things. So, the correct matching is as follows. Hope this is clear to you. Let us look at the next question. So, here a statement is given, assertion 1 meter can be written as 1 m and not as 1 m in the uppercase. Reason R is given if the unit of a physical quantity is not named after a scientist. Symbol of the unit should not be denoted with a capital letter. Capital letter means this is uppercase. Okay. So, you need to select the option which of the following is the correct option for this particular thing. Okay. So, first statement is clear for us. It should be written in the m in the lower case, but not in the uppercase. Fine. But what the reason says? If the unit of a physical quantity is not named after a scientist. Okay. Meter is the unit what we are talking about in the first statement, assertion. Is that the unit of a name of a scientist? No, right? So, now you go through this reason again. If the unit of a physical quantity is not named after a scientist, symbol of the unit should not be denoted with the capital letter. Capital letter in the sense uppercase letter. That is the explanation. So, it is very clear that the assertion is right, reason is also right, and this reason will be the correct explanation for the assertion. So, the answer will be the first one. A and R are correct, and R is a correct explanation for A. Hope this is clear for you. Let us see the next understanding based question. Write the following steps in sequential order to convert centimeter to millimeter. Okay. So, here we are given some steps. First statement, convert centimeter to meter by dividing the given value with 100. Next, write the given value.